Hello everyone. So today we are going to solve a question of Codechef which is asked in Starters 119 contest, Codechef contest. Okay. The question is K or sum and the question states that given two integers n and k, construct a permutation P of the integers such that there are exactly k indices. Okay, for which Pi plus 1 is odd. Okay. It can be proved that the answer always exists under the constraints of 1, k is greater than equal to 1 and less than equal to n minus 1. If multiple answers exist, any of them will be accepted. Okay. A permutation of 1, comma 2 dot n is a sequence in which every integer from 1 to n appears exactly once. So basically this is a permutation. And for example, if n equal to 4, then 4, 2, 1, 3, 1, 2, 3, 4. All these are permutation all which consist all the numbers from 1 to n. Okay, so let's understand this with a example. So if here we have n equal to 4, so we have to make a permutation of 4 length, and we have exactly two indices for which what is our condition? Pi plus 1 is odd. Okay, so in this permutation 4 plus 3, 7. 7 is odd. So this is one index. 3 plus 1, 4. This is an odd. This is not odd. So we cannot say that this is our indices which satisfy condition. 1 plus 2 is 3. So this 3 is odd. So we can say that this is also our indices which satisfy the condition. So we have in this permutation we have exactly two indices. Okay. So now let's understand this with a example. Let's say we have a value of n is equal to 3, n equal to 9, and k equal to 4. Okay, so we have to make a permutation of length 9 which have four indices, exactly four indices, for which pi plus pi plus 1 is equal to odd. Okay, so now we have to make permutation of 9 length. So let's I take 1, 2, 3, 4, 5. Okay, so this is indices. For this indices, this condition is satisfied. 1 plus 2 is 3, which is odd. So our answer is 1. Okay, and for this indices, this condition is satisfied. So we can say that this is also our indices. So 1, um, I'll take till now what is our answer? 1 plus 1. For this indices, condition is satisfied. So plus 1. For this indices, condition is satisfied, plus 1. So what am I doing? I just take all these four indices initially. Okay, now we don't need any indices and we do not take any indices. So for after 5, what we have to write here 7, because if we write here even value, then it is also our indices which satisfy this condition, and we have 5 indices. So and we need only 4 indices, exactly 4 indices. Okay, so here we have to take only odd number. So now this actually 2 1 plus 1 plus 1 plus 1. Okay, after that I have to take odd number only. But now what we are remaining? 6 and 8. And we have to take here 6 and 8 even number. And after that this indices also satisfy this indices will also satisfy this condition. And our and indices increases by 1 and we have 5 indices but we need only 4. Okay, so how we can solve this problem? So first, uh, I took all the necessary indices initially. Now in future I must have, I will have a condition which I will have a indices which satisfy this when we are uh, when we are switch odd to even, because we will have to switch odd to even because we need all the 9 integers from 1 to n. Okay, so what what will I do? First I take k minus 1 indices. Okay, so 1, 2, 3, 4. Okay, now this index is satisfied, this index is satisfied, this index is satisfied. So my answer is 1 plus 1 plus 1. Now 4. So let's say now next index is even because this cannot be satisfy this condition. Next index is 8. Now we cannot take here 10 because we have only take 9 integers from 1 to 9. So now I take odd 5. Next odd. Last odd is 3. Now we have to take 5. Okay. So this index is satisfy condition. Now next dot 7, next dot 9. So as this I make a permutation which satisfy this condition and this have exactly 9 integers from 1 to n. So what we did first, our n is 9 and k is 4. K is 4. So what we did, we simply print from 1 to k. Okay. Then we check if our k is even, then first print all even and then print all odd. Okay. And our if k is odd, then what we will do, we simply first we print all odd and then even. Okay. So what is the next even? Our last printed element is 4. So what is the next even? K plus 2. Okay. So now let's write it with better. So I print 1 to k. Okay. So if our k ampersand to equal to 0 means it's even. So what is our next even? Next even is k plus 2 and print all even. And what is our next odd? K plus 1 because we print all odds from 1 to k minus 1 if k is even. Okay. So print all or else. If our k is odd, so what is our next odd? Our next odd is k plus 2 and print all odd. And our next even is k plus 1 and print all evens. Okay, so this is how we will go. So now let's code this question. So first I will take a scanner as equal to new scanner system.in. Uh, I code in Java, but it doesn't matter because this is the pseudo code for this question and we code in any language. And t equal to sc.net. I take this in for test cases and while t minus minus is greater than 0. Okay, first we take integer n, then I take integer k. After that, we print from 1 to k. For int I equal to 1, I less than equal to k, I plus plus k. So system dot out dot print, what we have to print? I plus space. Okay, now if our k is odd, k is even. What is our next even? Our next even is k plus 2, and while our next even is less than equal to n, we print all the evens, all the remaining evens. The system dot out dot print next even plus space. Okay, and our next even is increases by 2. And what is our next dot? Which is equal to k plus 1, while next odd is less than equal to n. Then we print next odd plus space, and our next odd is increases by 2. And for k odd, I copy paste this condition. If it is not equal to 0, then I take this and I put this here. Our next odd is our k plus 2, and next even is k plus 1. And after that, we break the line. Println. Okay, now let's run this code. So code is run successfully. Now let's submit. So it is showing correct answers. So our code is submitted successfully. And here is the code. I hope you you understand. Thank you for watching.